welcome everyone to this class, and in this lesson we are going to talk about general circulation. General circulation is a term that we use to discuss about the flow of air around the globe, and if you look at Earth on a global scale, there are certain patterns that the air flow in or around the Earth. So before speaking about general circulation, there are a couple of things that we need to understand. There are a couple of phenomena that we need to understand to identify and to understand how general circulation works. So these are the two ideas that we need to remember. The first one is the difference in solar insolation. That means sunlight reaches different parts of Earth differently with respect to time and with respect to place. For example, in the equatorial region, we receive a lot of sunlight, but in the polar region, the amount of sunlight is less. And that changes with seasons as well. In the summer hemisphere, there will be more sunlight, and in the winter hemisphere, the sunlight will be less. So that's the first point that we need to remember to understand how general circulation works. The second point is the Coriolis effect. The Coriolis effect is something that happens because of the rotation of the Earth. The Coriolis effect is in fact the tendency to deviate from the direction of flow of the wind. So in the northern hemisphere, the wind will be directed or the wind will be deflected to the right side of its direction of flow, and in the southern hemisphere, it will be to the left side. So with these 2 points in mind, let us try to see what general circulation is. So in the earlier times, in around 1735, this man named George Hadley put forward a theory, and he developed this theory to understand how trade winds work. So what he proposed was what we can see in this picture. So in the equatorial region, we will receive more sunlight, and therefore the air will be warm. And we all know that warm air will rise up. So the air will rise up in the equatorial region, and once it reaches the tropopause, around 10 to 12 kilometers in the atmosphere, it will move towards the poles on both sides. So once it reaches around the polar region, the air will get cold, and it will sink down, and then it will move to the equatorial region around the surface. Well, this is what Sir George Hadley proposed, and he called each of these circulatory patterns Hadley's cell. So later we came to realize that this is not the case. There are mainly 3 reasons why this is not the case. So these are the 3 reasons. First one is the Earth is rotating. So what happened when Sir Hadley proposed that theory was that he didn't account for the rotation of the Earth. So the Coriolis force was not in the picture. So if you look here, in his proposal, he said that the wind will be moving from the pole to equator in a straight line. But that's not actually what happens. So that's the first thing. The second thing is that the irregularity in surface features. We know that the Earth is not uniform everywhere. We have mountains, we have deserts, we have oceans. So the surface of Earth is not uniform. So that's one factor that we have to take into consideration when we have to discuss general circulation. The third point is that the tilt in the axis of rotation. We know that the Earth rotates around axis, and that axis is tilted. That axis is not straight, and it is tilted. So the amount of sunlight varies. So these are the 3 points that make Sir George Hadley's assumption wrong. So then what actually happens is something like this. We have a 3-cell model where we have Hadley cell, we have a polar cell, and we have a feral cell. So there are 3 cells that are in action in the general circulation. It's something like this. So consider this is the equator, and we have the Tropic of Cancer and Tropic of Capricorn, which is at 23 degree and 23 degrees south and north. So as Hadley predicted, the sunlight will be more here and the air will rise up. And once it rises up to around 10 to 12 kilometers, it will start moving to the polar region. But it won't reach till the polar region, but around 30 degrees or around 20 to 30 degree latitudes on both sides, it will cool and it will sink down. And once it reaches here, it will move back to the equator. There are a couple of features that are visible on the planet because of this effect. Since the air is moving up in this particular direction, we have a lot of clouds forming over here, and that is one reason why we have the rainforest on Earth focused on the equatorial region or the tropics. And on these two sides, the Tropic of Capricorn and Tropic of Cancer, the air will be moving down, resulting to clear skies and less clouds. And that is the reason why we have the major deserts in our planet in these two regions. So this is the first cycle, which is called the Hartley cell. The second one, opposite to that, happens on the polar region. In the polar region, the air is cooler and it will sink. And once it sinks down, it will move to the equatorial region. Around 60 degrees north and 60 degrees south, the air will warm and it will rise up. And once it reaches tropopause, it will move back to the polar region. So this cell is called polar cell. It is opposite to what happens in the Hartley cell. Between these two cells, we have another cell which is called feral cell, and this cell is fundamentally different from the polar cell and Hartley cell. That is, the Hartley cell and polar cell are temperature oriented or temperature driven cells, thermal cells we can say, because these two cells work because of the temperature difference in these two regions. But the feral cell is somewhat like a mechanical cell. It acts in the opposite direction of the polar cell and Hartley cell. The air will come down here. Some of it will move in the equatorial region and some of it will move to the polar region. And the air rising up will move to here and to here. So the feral cell is formed because of the action of these two cells, like a mechanical gear. So in short, we have a 3-cell pattern: the Hartley cell, the feral cell, and the polar cell. So as I have explained earlier, these are the tropical rainforests. We can see that these all form in the equatorial region, where we have warm air which is rising upwards, creating a lot of clouds and resulting in a lot of rain. So similar to that, something happens around 60 degree north and south, where we have a temperate forest. The areas of Britain getting a lot of rainfall is one of the reasons behind the what's happening over here. We can see we have a rising trend here, which creates a lot of clouds here. So there will be a lot of rain in this particular region. So that's what happens here. And we have desert regions around this region because we have air descending down in that particular region, and there are a lot of clear skies and less rain. And if we look at the surface pattern of the winds, the air will sink down and it will move back to some of it will move back to the equatorial region and some of it will move back to the polar region. Here is when the Coriolis effect comes into play. So the air won't be moving in a straight line, rather it will be deflected to its to a side of its rotation based on the hemisphere. So in the northern hemisphere, the wind will be moving to its right. So from the subtropical high, that is the 30 degrees, the air will be moving to the equatorial region, but it will have a rightward shift. And the air that is moving to the polar region will also have a rightward shift. The same happens here as well. In the southern hemisphere, the wind will be moving to the left. So we have a wind pattern as we can see here, and here also we have a wind pattern here. And these winds were used by the Europeans in the 18th century and 19th century for trade purposes. That's why these are called the trade winds. And these winds are called the subpolar westerlies, which are from the west to the east. So this is the surface pattern of the general circulation. If we look at these 3 cells, we have a junction here and here, where the general difference in the nature of air, because we have cold air here and we have a warm air here. So there are like these junctions here, and in these junctions, streams of air form, and these are called jet streams. We have basically 4 jet streams that circulates the planet, and this one is called the polar jet stream and this one is called the subtropical jet stream. So if we look on a different picture, so we have 2 jet streams on each hemisphere. This one is the polar jet stream and this one is the subtropical jet stream on either sides. So these are the fundamental features that are related to general circulation. We'll see about more of this in the coming lessons. Thank you.